Hi again. Now, when we're talking about significant results using probabilities, it's a little bit different. We just don't have three buckets to choose from. You don't have just, you say, okay, where does this value fall? Does it fall low? Does it fall in the middle? Does it fall on the high end? It's not quite the same thing. Now, we talked a little bit about this in 4.1, but we're going to do it a little bit more so right now. So when we have a significantly high number of successes for a specific value of x, we're not just looking at x. We're looking at that value and anything above that in terms of probabilities. So we have to look at all the probabilities from that value and up, and then add those all together. That's the way we're going to look at it. And we want to see what that total probability is compared to 5% or 0.05. If it's smaller, that's when it tells us that it's significantly high. So again, think of that number line. If we have that number line and we have 0 and 100, or 0 and 100. So if we're at 100 and we want to look at, see if something is close to that as far as it being high, we want to know if we're at a specific value and we have all these other probabilities above it, how close, if we add them all together, how close to 100% are we? Are we within 5% or are we more than 5%? Because if we're more than 5%, that pushes us into the middle, which is not significant. And it's very, very similar on the low end. The low end says if X successes among intervals is a significantly low number, then X or fewer is less than 5%. So now if you're on the low end and you're at 0, how close to 0 are you? You know, I have to look at that value, that probability of that value, and all the probabilities below it, and add those together and see if it's less than 5%. If it's less than 5%, that means it's low. If it's more than 5%, again, that pushes it into the middle, and that means it's not significant. So, now the rare event rule for inferential statistics, this is just a repeat of what we said back in chapter 4, so I'm going to skip that. And then there's the example down here below that just kind of reinforces it. So if it doesn't make sense and you want more clarity on it, definitely let me know. I'm going to skip right to the example because it jumps into this significance concept. A sociologist randomly selects single adults for different groups of 6. And the random variable X is the number in the group who say that the most fun way to flirt is in person. Ooh. Using the accompanying table, is 4 adults a significantly high number of adults who say that the most fun way to flirt is in person? Is 5 adults high? Is 1 adult significantly low? Is 0 adults significantly low? Why or why not? So, let's answer the first one. Is 4 adults significantly high? Well, is 4 significantly high? To answer that question, we have to look at the probability of 4, which is right here, but we also have to look at all the ones above that. So we have to look at this probability and this probability as well. So we need the probability of 4 plus the probability of 5 plus the probability of 6. So if we add all 3 of these probabilities up, we want to compare it to 5%. So let's add them up real quick. 0.116 plus 0.037 plus 0.012 equals 0.165. So how does that compare to 5%? Is it less? No, no way. It's bigger than 5%. So remember, if we're at 100, we're basically pushed back 16.5%. So we're definitely not close to 100%. We're beyond that 5% threshold. So once you get beyond that, that means it's not significant. You're in the middle. And if you're in the middle, you're not significant. Oh well. So this is going to be a no. It's not significantly high. Let's take a look at the next one. Is 5 adults significantly high? Well, so now 4 is out of the picture. All we care about is 5 and up. So we don't even need 4 anymore. We just need 5 and 6. So if we looked at the probability of 5 plus the probability of 6, what do those two add up to? Well, I think we can do that without a calculator. So we got a 4, we got a 9, so 0.049. Well, that, my friends, is less than 5%, 0.05. So this is less than 0.05. So is 5 significantly high? That's a yes. Because it's less than 5%, this was greater than 5%. So that means it's really close, just barely close enough to 100% to be less than 5% from it. So again, we're looking at just the high end. But if we're looking at the low end, it's just a slightly different concept. If we wanted to look at is one adult significantly low, well, so now we got to look at 1. And we got to look at everything below 1. So we got to look at 0 as well. So both of those will determine together whether or not 1 is low. So we need the probability of 1 and the probability of 0. So we can add that up without a calculator, 0.093. How does that compare to 5%? It's bigger, right? It's bigger than 0.05. So the answer is no. It's not significantly low. Again, if you're at 0, you're 9.3% away from it. So you're beyond that 5%. You're in the middle. You're not significant. And let's do one more. Is 0 low? Well, if we're looking at 0 and below 0, well, there's nothing below 0. So in this case, we're only looking at 0 to make this determination. So the probability of 0 equals 0.041, which is less than 0.05. So that is a yes. So it's definitely a little different than the range rule of thumb. You have to look at multiple situations here, or multiple probabilities that contribute to that significance, not just a single probability. That's the key. So I'm going to have an example that's even more expansive than this one as a handout. So I'm going to try to get that uploaded shortly. But for now, hopefully this kind of gives you a little bit of better understanding of how this works. So we're going to have one more video which takes care of the last question, and it puts it all together. So see you in a minute.